Hello, this is Jack Jackson. In this video, we're going to summarize very quickly a short table of integrals that we use in the Survey of Calculus class. This will be part of a larger list that we use in the Calculus 1 class. So in these rules below, b, n, and c are constants, u and v are functions of x. So we've got a few rules for, first of all, for combining functions. The antiderivative of u of x plus v of x dx is the antiderivative of u of x plus the antiderivative of v of x. So the integral of the sum is the sum of the integrals. The antiderivative of c times u of x dx is c times u of x dx. So if this c is a constant, as long as it's a factor here, if you can factor the c out and get it out here where it's c times something, then you can bring it in and out of that integral sign at will. And we've seen how that's very useful for us in working out what du is sometimes for substitutions. A special substitution is called integration by parts. If we can do two substitutions for u and dv, as we saw in our previous video, we can write that integral of u dv as uv minus the integral of v du. In Survey of Calculus and Calculus 1, this is probably going to be the most advanced technique, so we're going to do integration by parts really kind of as a last resort. On the other hand, when you're in Calculus 2, it may be one of the first things you try right after just a u substitution. Now notice these don't really find an antiderivative all the way. What they do is rewrite one antiderivative or one integral in terms of one or more other integrals, and hopefully these integrals on the right side are easier to work with. Now we just have a very limited number of functions that we know how to actually do an antiderivative for. The integral of 0 dx is a constant. The derivative of a constant dx, n dx, is nx plus another constant here. And we could do power functions. The integral of u to the n is u to the n plus 1 times 1 over n plus 1 plus c. And that works for anything except for n equals -1. Notice when n is -1, this rule would give you dividing by 0, so that's certainly not going to work. But if n is -1, you've got the integral of u to the -1 du, or the integral of 1 over u du, and we know that that is ln of u, absolute value of u, plus c. ln absolute value of u plus c. And then we know that for exponential functions, in general, we have the antiderivative of b to the u du is b to the u divided by the logarithm of b plus c. And of course, a special case of that is the antiderivative of e to the u du is just e to the u plus c. Now notice all these have a plus c in them. And those are all the basic rules that we really need to do any of the problems that we're going to encounter in a Survey of Calculus class. Now like I said, in Calculus 1, we're going to learn, we'll look at a few more, including some things dealing, say, with some trig functions and so forth. But for Survey of Calculus, this is the full list. Now, in fact, I have a couple of videos after this that are going to be my next two in my list, and these are actually these are videos going over solutions to a practice test that I used in Survey of Calculus a few years ago, or a few semesters back. And these problems deal with actually some stuff from our last unit or our last playlist here, where we were talking about concepts of integration of definite integrals. They also have problems dealing with what we're doing in this playlist with finding antiderivatives and using those to find definite integrals using the fundamental theorem of calculus. And there's also a few application problems that we really won't get into in more detail until our next playlist. But I think you'll find that you should be able to follow my solutions even on the parts that we haven't gotten to yet, and see some applications of integration as well. First little taste of that, a little preview, as we look at those two playlists that are coming up, those two videos that are coming up. After that, we'll come back and we'll talk about a topic called improper integrals. There might even be an improper integral in one of these videos here as well. So in a way, these might be a little bit misplaced, but let's go ahead and watch them next, and then you can come back to them if you need to.